basically last video that I did was I made a habitable solar system, but the star was a white dwarf slash pulsar kind of thing, but it was an old, very old star. So what we're going to do in this video is we're going to be doing something different. We're going to be basically trying to see if a oh, that's dark. That is. That's it's very dim. Now basically we're going to be trying to make a habitable planet around a brown dwarf. So already we can see that hopefully this is going to stay habitable, should I say. No, hang on. Is that going to stay habitable? No, not. Let's put it to. And the answer is no. Just no. No. Now, increase the mass slightly. Alright, think about this, right? This is a brown dwarf. Very young brown dwarf. So it's spinning pretty fast. Alright, so it's spinning incredibly fast, and it's surrounded by, I don't know, probably like a massive, absolutely massive ring of material. Like, not huge, but big enough to actually say, like, damn. I can barely see those chunks. Now, let me just 100. Now, I apologize for the frame rate lag. Alright, so this is a young brown dwarf, right? So what we're going to do first is we're going to stick a gas giant in orbit, newly formed gas giant. So it's like, I don't know, it's orbiting this brown dwarf, and it's, I don't know, it's a new gas giant, so it's pretty fucking hot, to be honest. It's only about 1400 degrees Celsius. Probably not that hot, probably a little bit cooler than that. Turn the temperature down so that the planet doesn't bloody boil. Let's just get rid of. Let's make it nearly completely hydrogen. Right, so I don't know why material's this close to the star. So how do we go from a disk of dust to planetary bodies? Answer is really, really big planet. Very large gas giant, I'll tell you that. Now what we're gonna do is we are going to remove. Hang on, no, wait, no. We're going to get rid of you. Get rid of you. Get rid of you. See how that works out. Might wanna get some of this as well. Hang on guys, I'm sorry. Let me just get rid of the inner cloud of stuff. I see it gone. There you go. No, that doesn't even exist anymore. So now it's just surrounded by this disc of crap. And we are just going to wait, is this this isn't collapsing in mass, is it? No, it's not. Is it gaining mass? I don't know. It is swallowing a lot of this stuff up. Let's turn off the zone. Oh my god, it's just eating up a lot of this stuff. It's just gobbling up. So basically this is a brown dwarf with a large-ish gas giant. Like, it's not that big compared to like Jupiter. Alright, it is probably big compared to Jupiter, but it's still smallish gas giant. It's only like 35 Earths in mass, but it's still 48,000 kilometers radius. So what we're gonna do, just to make this slightly more interesting, we are going to put you on a slightly inclined orbit, and we're going to see what happens. Probably not that. Probably not that much. Probably about there. See what happens there. And it's already starting to mess up the ring system, really. So what we can see here is the gas giant is it, hang on, just want to see, is it actually starting to, yeah, you can, this is possibly one of the dimmest stars I've ever seen. Such a dim star. Now, what's interesting here is you can almost like see with the with the Saturn and its rings video, Universe Sandbox 2 video that I made and I uploaded to YouTube, the same thing is happening here, but it's a star with a planet instead of a planet and a moon. Now we can see like gaps in the ring system. That is actually that tells us a lot of how a gas giant affects its mother star and the protoplanetary disk that it forms from. Now normally it is the gas giant that originates, that forms from the disk first, because most of the time you need a gas giant there to kick off other planets to form. So I don't know, say a new gas giant forms around here. Alright, so this one's going to be about 21 Earths. Alright, and it's going to have some water, some silicates. It's going to have no iron because this has hardly no iron in it. So now we're going to see what happens with this planetary system. So right now, what we can see here is this planet it's also quite young, it's spinning, God knows crap, I don't know what else. It's on an axis, it's similar to Saturn really, and it's again, just like its sister planet, it's starting to gobble up the surrounding asteroids and comets and things like that. It's starting to clear its neighbourhood. That's what a planet is. But really that's not entirely true, right? They used to say for like a object to be a planet, it needs to clear its neighbourhood. Not entirely true, because practically all the planets in our solar system have not cleared their neighbourhood. Like for example, Jupiter, it still has like groups of asteroids in its orbit, so it hasn't technically cleared its orbit. It's still got a lot of material swirling around it. So what we're going to do is we're going to trails. So, okay. So right now, we can see that these two gas giants, they are still feasting on the surrounding surrounding dust and gas. Well, it's not really gas, it's more dust, because all the gas has been swallowed by these two massive gas giants. Well, they're big in the system, they're massive in the system. They're practically the same size as the brown dwarf. Now, we're gonna call this brown dwarf. Alright, let's name it again. Brown dwarf. What on earth is going on? Hang on, guys. Hang on. Brown dwarf. There you go. Brown dwarf. Here you go, guys. Now turn labels on. So we got a brown dwarf. Oh, there's no mistake. There you go. Got a brown dwarf, and the planets, they are still eating at the disk. Okay. Okay, I know what to do. Okay. I have an idea. I have an idea. Ooh, you're gonna love this idea. So what I'm gonna do is I'm going to reverse this orbit. So it orbits in the opposite direction to the other planets. So it's in a retrograde orbit. It's going to be mostly made out of water, because why not? Because it's awesome that way. Now, you guys are possibly like thinking, like, why would you put that gas giant in a retrograde orbit around the brown dwarf star in between of two gas giants that are larger than the planet that you just put in? Reason why is because the gas giant that I just put in is to almost like stabilize the system, to stop the other two larger gas giants, to stop them from competing for space. So this gas giant here really acts as like a barrier between these two gas giants. This gas giant is just eating away at this. You can see the destruction they are causing. They are flinging asteroids left, right, centre. And you got this gas giant, it's just going at its just normal pace around the star. So, I mean, orbits are starting to become a little bit misshaped, but that does tend to happen with objects going in retrograde to their mother star. Oh, I'll turn it on, thank you. Turn that down slightly. So, what we can, oh right, it's just amazing. What we can see here is there used to be a lot more asteroids and comets around, particularly around here, and it's just been cleared out. So we've got this left. That's all we've got left. It's just this. So what we're gonna do is we're gonna add in, I don't know, probably a couple rocky worlds. How close are the? I could probably add in a couple. Hopefully this planet doesn't start to get ripped to shreds. I don't think it's starting to get ripped to shreds. Now, oh, that planet has heated. It's heated up. It's obviously been smacked really hard by something. It's starting to cool down now, but still, that was a massive hit. Whatever hit it, I don't know what hit it, but whatever hit it was a massive smack for it, to be honest. We're gonna stick a atmosphere around this planet, so about 98.3. So just a tad difference to Earth's atmosphere, but that it will be expected. The planet's still quite young. I mean, oh god. It's on a it's on an axis that's just unprecedented. So right now the planet is, well, practically all the planets are still quite young. This planet here, it orbits its star in 2 days. 2 days. That's insane. This asteroid field extends all the way out to like around here. So this is a, ooh, that's an odd colourful gas giant. We can see that. Oh, I thought I selected Saturn, and I thought like, oh, that's a bit odd. Now, to be honest, I don't understand why Saturn is the colour that it normally is. Now, Uranus is greener than Neptune. Don't know why it is, but it is. Now, Neptune is heavier than Uranus, but it's smaller. And that's because it's got more water ice in it than Uranus. Uranus is more hydrogen. So now, oh, we can see an asteroid field forming here. That's really nice. And this planet here, its orbit is starting to get elliptical. So we want to watch out for that. I mean, this planet's orbit is okay. This planet, you know what, guys? This is interesting because now think of this: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus. I know that if this was like our system, I know that Saturn would be on a retrograde orbit, but we need this gas giant to be on a retrograde orbit, or otherwise our system would completely fall apart. Now, this planet's orbit is getting more and more elliptical, and that's because of the gravitational influence from the 5th planet out, that is the gas giant called Onater, I think it's called, and from Antus, but also the gravitational influence from Pietus, I can't even pronounce that. Also, it gets affected by its sister planets like Juturu, a Poangi, I think it's called, and also Chipoli, I think it's called. I'm not entirely sure. So that's a couple of reasons why its orbit's getting more elongated. But the 4th planet out, that is Juturu. It's well, its orbit is becoming like it's not round really. It's more like a oblong. So, I mean, if I orbit as fast as the most inner asteroids are orbiting, that is pretty fast, to be honest. That is really fast. So if this really was a brown dwarf system, like this brown dwarf still, like say this brown dwarf is literally, it's like the smallest red dwarf, it is 0.10001% smaller than the red dwarf, than a red dwarf. So it's literally incredibly close to fusion. I mean, it is practically fusion, but all it really needs is an asteroid just to smack into it. And so, say like, I don't know, a small gas giant came in, smacked into this brown dwarf and ignited it. So now it is technically a ultra cool red dwarf. Now it's got this ring of material around it, it's got 3 gas giants and 4 rocky planets. It's got an asteroid belt, it's got a Kuiper belt, and it's still got quite a lot of debris in the inner parts. So what I'm going to do is I'm going to actually probably not that. Probably slightly darker, probably about like, wait, how do they make it grey again? Oh, it's like brightness. So what we technically got here is we got the main gas giant, and we've just got like that is a really nice looking Kuiper belt. Seriously, a really nice looking Kuiper belt. So what we're gonna do is we're gonna make this as a convert body to convert thing to like fragment. That's a nice looking. Surface gravity is like, what's that compared to Earth? 0.00000000351 Earth gravity. Really, it's just stupid. All you have to do is literally just walk. Just take one step and you just like escape velocity. Give me a second. Okay. How long does it take to orbit its parent star? 18 days to orbit its parent star. 18 days. 18 goddamn days. And to be honest, most of these objects, they are not on circular orbits. Like this one I've just converted into like a tiny asteroid. It's literally 4 centimeters in radius. And it's 1 kilogram in mass. Density is like 2.8 grams centimeter cubed. It's going at 20.1 kilometers a second. That's pretty fast. But with this object, it did like millions of objects in this simulation right now. It's not on a circular orbit. If it was on a circular orbit, it would be pretty boring, but it's not. And I think it's on a, yeah, it is on a inclined orbit. So tidal power is constantly, tidal power is constantly turning on and off. So this is just what we're gonna do is we're gonna make this over to every day. Hello? No? You're not gonna rotate? Okay. I'm fine with that. Let's call this Morph. Morph. So this asteroid, this asteroid, it will literally just like, it's only it's just under 4.5 centimeters in radius, and like you can see most of these objects, the Kuiper belt is getting, well, the so-called Kuiper belt is getting larger and larger and larger because more and more. This object is just really far out. This object is even further out. See if I can find any other objects that have been thrown out further. I can't see any. I can't even detect any. So this is practically the furthest object from this system. It is really going for some spin. It's quite dark out here. I think that's right. A forming protoplanet is being kicked out. So I don't know, probably about like here, and he's barely getting any light from his parent star. Let's just really mess it up. Let's just mess up its day a significant amount. Let's give it an atmosphere. Let's give it some water. Should we give it a slight magnetic field just to slight magnetosphere? This magnetic field is just getting smaller and smaller and smaller. So this has like a quite sparse magnetic field. So I mean, it's not ideal for having an atmosphere, but still. So it's basically, this has gone from a cloud of debris around a ultra cool brown, a super hot brown dwarf, right? A brown dwarf that's ignited, to it having planets and this is a real good question. Oh my god, it supports life. It supports life. This planet supports life. We have made life on a planet around what is technically a red dwarf slash brown dwarf star. Like, probably call it probably a ultra hot brown dwarf. So yeah, thank you for watching, guys. I hope that you liked this video. If you do, don't forget to leave a comment also don't forget to subscribe, like and share this video. If you want, leave a comment on what Universe Sandbox 2 video you want me to make next. If you want me to prove a fact, or if you wanted me to prove something is real or fake, or if you wanted me to make something crazy, just put it in the comment and it will be awesome. Thank you for watching. Hope that you really like this video, and this is the Just Move signing out.